Welcome to the debate. The framework for today's discussion features a design by a hut. So I want you to imagine waking up to find that the most valuable technology company in the world just lost $600 billion in stock value in a single day,
Yeah, that's a massive hit.
right? And not because of a scandal or, an economic crash, but because a small laboratory on the other side of the world proved that you just don't actually need their super expensive hardware to build the future.
Which is exactly what happened recently. I mean, it completely changed how we have to look at this whole global race for artificial intelligence.
Exactly. So today, we are exploring a really massive high-stakes issue, which is the AI power war. The United States and China are in this fierce competition to control the future of AI. But this isn't just a contest to see who can write, the smartest software.
No, not at all.
It's a fundamental clash of strategies. It's really a race between high-tech computer chips on one side and just basic raw electricity on the other.
And the stakes really couldn't be higher here because, whoever controls AI is likely going to control the global economy for the next century.
Right. So I will argue that America's huge lead in advanced chips, along with our, bold new technology, will win the AI race.
And I will argue that China will win because AI needs massive amounts of electricity. And, well, China's building power grids much faster than the US.
Okay, so let's start right at the foundation of the American strategy, which is computing power, or, what we in the industry call compute.
Right, the raw muscle.
Exactly. Compute is just the raw math power required to train a massive AI brain. If you want a smarter AI, well, you need more compute. And right now, the United States is miles ahead. I mean, we currently control about 74% of the world's high-end AI compute, while China only holds about 14%.
I mean, that is a very big gap.
It's massive. And the U.S. has actively worked to protect that lead, using a choke point strategy. We placed strict export controls on the absolute best technology, like we blocked American companies from selling the fastest NVIDIA chips to China.
Yeah, the really high-end stuff.
Right. We blocked access to TSMC, which are those highly advanced factories in Taiwan that physically build the chips. We even blocked a company called ASML from selling their machines.
And those are crucial.
They are. ASML makes these incredible devices that use light to draw microscopic circuits. And without them, you simply cannot manufacture modern chips. So by controlling the hardware, the U.S. controls the pace of the whole race.
Well, I come at it from a different way. Because that choke point strategy, it was based on a huge assumption. The U.S. assumed that if you just, starve China of the newest chips, you freeze them in place.
That makes sense logically, though.
It does. But that strategy just completely backfired. Which brings us back to that $600 billion market shock, what people are calling the DeepSeek shock.
Right. The AI model that was released by a Chinese lab.
Exactly. DeepSeek built a world-class AI model that actually competes with the best American systems. But here is the crazy part. The American company OpenAI spent an estimated $100 million training their biggest model. But DeepSeek, they achieved similar results for only $5.6 million.
Wow, that's a huge difference.
It's a massive difference, and they did it using older, downgraded chips called the H800. The U.S. actually allowed those chips to be sold because, well, Washington thought they were too slow to be a threat.
Okay, so DeepSeek's model is definitely an impressive piece of engineering. But let's look at the reality of export controls for a second. I know people like to say controls don't work if someone finds a way around them, but export controls are not a solid concrete wall.
What do you mean?
They're more like a toll booth. Export controls are like building a dam on a river, right? The water might eventually find a way around, but doesn't the dam still slow down the flood? China was moving incredibly fast, so the US set up a toll booth to slow them down and make their journey much harder and much more expensive. DeepSeek is a great achievement, but doesn't the toll booth still slow down their overall progress?
I actually like that toll booth analogy. But here's the problem with it. China didn't just get stuck in traffic paying the toll. They got off the road and built a completely new highway.
A new highway?
Yeah. History shows us this over and over again. When you block a country from getting the best tools, you don't stop them. You force them to get creative. Necessity makes people creative. When you block a country, They find a cheaper, better way.
But how exactly do you innovate your way out of a physical hardware limit? I mean, a slower chip is a slower chip. You can't just wish it to be faster.
You don't wish it to be faster. You do it through brilliant software engineering. See, DeepSeek didn't just write basic code. They changed the rules of the game by changing the architecture. They used a technique called a mixture of experts.
Okay, explain that simply for us.
Sure. Think about how a human brain works. When you are asked to solve a math problem, you don't use the part of your brain that remembers how to ride a bicycle. You only activate the specific neurons you need for the math problem.
Oh, okay. So instead of running the entire AI model for every single question, the system only activates a tiny piece of the model?
Exactly. And that saves massive amounts of compute. Because DeepSeek engineers only had those older, downgraded chips. They had to squeeze every single drop of performance out of them. They couldn't rely on brute hardware power. So they made their software extremely efficient.
I see.
And now that they have built this hyper-efficient architecture, they know how to use it forever. Basically, the U.S. choke point strategy accidentally trained China to be perfectly efficient.
Okay, I see the logic there. Software optimization is fantastic, but eventually you do hit a physical wall. Software still needs hardware to run. You cannot run a futuristic citywide AI system on a pocket calculator, no matter how clever your code is.
Sure, you need some hardware.
Right, and the US is scaling up that hardware like never before. I mean, American companies are pouring hundreds of billions of dollars into building the largest computer data centers in human history.
But that physical wall you mentioned, that is exactly why electricity is the real issue here. DeepSeek completely changed the rules from chips to power. The limit is no longer about getting the most expensive chips. The new limit is just getting enough power to turn the servers on.
Let's unpack that a bit. Why does cheaper software make electricity the main bottleneck?
Because of a famous rule in economics called the Jevons paradox.
The Jevons paradox. Okay.
Yep, let's go back to the 1800s. There was an inventor named James Watt, and he created a much better, much more efficient steam engine. Now, if the engine is more efficient, you would naturally think society would use less coal, right?
Right, because if the engine does the exact same amount of work but uses less fuel, your coal usage should drop.
That is exactly what everyone thought. But the exact opposite happened. Because the new steam engines were so cheap and efficient to run, people started putting them everywhere.
Oh, I see.
Yeah. They put them in boats, trains, hundreds of new factories. Because the technology became so accessible, the total amount of coal used by the world absolutely skyrocketed. That is the Jevons paradox. When things become cheaper and more efficient, people use them more, not less. Efficiency explodes demand.
So you are saying DeepSeek is basically the new steam engine?
Exactly. DeepSeek proved that world-class AI can be cheap and highly efficient. And because it is cheap, it will soon be everywhere. We won't just use AI for, writing emails.
Right, it'll be in everything.
Exactly. We will use it to run massive farms, navigate millions of delivery trucks, design new medicines, and manage city traffic lights. All of that requires millions of computer servers running 24 hours a day. And what do all those servers need to run?
Well, they need electricity.
Massive amounts of it. The real limit in this global race is not the tiny silicon chip anymore. It is the giant power plant. And this is where China is completely crushing the United States.
Okay, I want to look closely at those numbers because we hear a lot about China's infrastructure. How wide is the power gap right now?
It is staggering. So China currently has 3,200 gigawatts of electrical capacity. The United States only has 1,293 gigawatts.
Wow.
Yeah, China's power grid is more than 2.5 times larger than America's.
So just to put a gigawatt into perspective for our listeners, 1 gigawatt is roughly enough electricity to power about 750,000 homes.
Exactly. And now listen to their growth rate. In the year 2024 alone, China added over 400 gigawatts of new power capacity to their grid.
Just in 1 year?
Just in 12 months. Think about the math on that. They built enough new power to supply hundreds of millions of homes. That single year of construction is more than the total power capacity of most countries on Earth.
Okay, those numbers are real, I acknowledge that, but the location of that power matters deeply. Yes, China's throwing up solar panels and wind turbines everywhere, but they are building a lot of them way out in the Gobi Desert or in the remote mountains in the west.
True.
And their tech companies, their big cities, and their engineers are all thousands of miles away on the eastern coast.
You're right about the geography, but they aren't trying to move the electricity. They have a master plan called East Data, West Computing.
Because moving electricity over long distances is incredibly wasteful, right? You lose a huge percentage of the power just pushing it through the transmission wires.
Exactly. So China doesn't push the electricity. They build the AI data center right in the middle of the desert, right next to the giant solar farm. They plug the computers directly into the cheap green energy source.
Ah,
Right. And once the AI does its thinking, it sends the data back to the eastern cities. Moving data through fiber optic cables is fast, cheap, and loses almost no energy. It is a perfectly matched system.
I'll admit, the East Data, West Computing plan is highly organized, and the United States is definitely facing a major transmission bottleneck. I mean, right now in the US, there are data centers waiting for a combined 241 gigawatts of electricity. They're just sitting in line, waiting for the power grid to connect them.
And they will be waiting a long time.
It's true, unfortunately. It can take 5 to 10 years just to get a permit to build a new high-voltage power line across state borders in America.
10 years?
Yeah. We have thousands of local regulations. We deal with the not in my backyard effect. People want the magic of AI on their phones, but they will literally fight in court to stop a power line from being built near their neighborhood.
I mean, your grid is stuck in a giant legal traffic jam. You can't even get a local permit to run a wire from one town to the next. So how can the U.S. possibly win an AI race when you can't even legally turn the computers on?
Because America's defining strength is leapfrogging the problem. When we hit a massive physical barrier, we don't just give up. We use extreme innovation to jump completely over it.
Okay, like what?
Look at nuclear power. Major U.S. technology companies are tired of waiting for the traditional grid, so they are just buying their own power plants. A massive tech giant recently signed a deal to physically restart the 3 Mile Island nuclear plant.
I mean, nuclear power is excellent because it runs constantly, day and night. But restarting a few old reactors is a tiny drop in the bucket compared to what AI requires.
Well, it is just the first step. Tech companies are pouring billions into next-generation small modular reactors.
I'm sorry, but I just don't buy that timeline. Let me tell you why. Building new nuclear tech in America takes decades because of safety testing and regulations. China is not waiting for next-generation science projects. They are physically pouring concrete today.
Sure, but
They are building 30 new traditional nuclear reactors right now. Over half of all the new nuclear plants in the world are currently being built in China.
okay, then let's look at a leapfrog solution that completely bypasses earthly permits. And I know what you were thinking as a listener. This next idea sounds absolutely ridiculous at first, but the U.S. tech sector is seriously developing orbital data centers.
Wait, really?
Yes. We are looking at putting massive AI computer servers into space.
Putting servers in space? Putting data centers in space because you can't get a building permit on Earth is like, I don't know, trying to live on the moon because your city's rent is too high.
I know, it sounds wild.
It really does.
But look at the actual physics and economics of it. Why are data centers limited on Earth? Because of land costs, local zoning laws, and the limits of solar power. Down here, the sun sets every night, and clouds block the light.
Okay.
But in low Earth orbit, the sun shines constantly. There are absolutely no clouds. A solar panel in space captures constant 24-hour energy.
Okay, I'll give you that the energy is constant. But what about the heat? AI servers run incredibly hot. Down on Earth, we use massive air conditioners and millions of gallons of water to cool them down. Space is cold, yes, but it is a vacuum. There is no air.
That is an engineering challenge, absolutely.
A huge one. Heat doesn't just float away in a vacuum because there is no air to carry the heat off the machine. Your computers would melt.
Right, so you would need advanced liquid cooling loops and giant thermal radiators to push the heat out into the void.
But companies like SpaceX are dropping the cost of launching a rocket every single year. If launch costs get cheap enough, building a solar-powered AI data center in orbit solves the land problem, it solves the energy problem, and it requires zero local permits.
I still think that is an incredibly risky gamble. I mean, what happens when a hard drive fails or a server breaks? You can't just send the mechanic in a van. You have to launch a rocket.
That's fair.
And what about the latency? Sending a signal from a user's phone up into space, processing it, and sending it back down takes time. It takes milliseconds. If an AI is controlling a self-driving car moving at 70 miles per hour, you cannot afford to wait for a signal to bounce off a satellite.
Latency is a factor for real-time robotics, yes. But for training massive AI models, which takes months of continuous computing, latency doesn't matter at all. The training can happen entirely in orbit.
It is still a massive stretch. You are basically comparing American science fiction dreams against Chinese concrete. America is making highly risky bets on space computers and experimental nuclear reactors. Meanwhile, China is laying cable, building dams, and turning on hundreds of gigawatts of real, usable power today.
But that is exactly the difference in our strategies. China relies on brute force. They are throwing massive amounts of concrete, coal, and money at the problem. America relies on disruptive innovation.
But innovation doesn't power a grid.
It shapes the future, though. DeepSeek was a clever software trick, yes, but American companies are still holding the world's absolute best hardware. By the time China completely copies today's technology, the US will have invented the totally next generation of chips.
But remember the Jevons paradox. You cannot escape the math here. The faster and better American chips get, the more demand there will be to use them. Every time you invent a faster chip, you worsen your own electricity crisis. You are basically building a massive, hyper-advanced race car, but you only have a 1-gallon gas tank. And China? China is building an endless gas station.
I think this is a perfect place to draw our thoughts together. Let's provide a really clear, simple summary of where we both stand for the listener.
Sounds good.
So, I have argued today that the US strategy relies on having the best technology. We hold the dominant market share in advanced computer chips. And when we face massive roadblocks, like our slow power grid, we don't just accept defeat. We invent totally new solutions, like space computers and new nuclear plants, to jump over obstacles.
And I have argued that China's strategy relies on extreme efficiency, like we saw with DeepSeek, and massive practical production. They realize that AI needs electricity above all else, and they are building the massive power grids required to win.
Looking at this entire debate, it deeply reminds me of a historical concept called the Thucydides trap.
Ah, right.
Yeah, it's a pattern we see throughout history. It describes the dangerous tension that happens when a rapidly rising power challenges an established, older power.
And the AI power war is really the ultimate modern version of that trap, because this isn't just about who gets to make a cooler smartphone app.
Exactly. It is about who will control the systems of human society. I mean, within a decade, AI systems will likely manage our hospitals, direct our financial markets, and optimize our military defenses. Whoever commands the best AI commands the global future.
It's a profound turning point, and the winner will be determined by whether the future belongs to the smartest microchip or the largest electrical grid. It is just a fascinating tension.
It really is. And the final chapter of this story is actively being written right now. So, we encourage you, our listener, to dive into the source material, think deeply about the facts we've explored today.
Yeah, look at the evidence and decide for yourself.
Exactly. Decide which strategy holds the ultimate advantage. Will it be the technological leaps of the United States or the massive energy dominance of China? Can a toll booth made of advanced technology really slow down a rising tide of pure energy? That is the question we leave you with today. Thank you for joining us on the debate.